Okay, page 2, the third problem. I go to factor this, and a few of you had questions on factoring. It has 3 terms, so you could try to use synthetic division if you want. But when you see that it's a quadratic, this is really a quadratic because it's x to the 4th and then an x squared. So when you see that it's really a quadratic, you can still draw your parentheses and ask yourself, how do you get x to the 4th? X squared times x squared. How do you get 16 plus 4 and plus 4? So that you're getting your x to the 4th. For your middle term, you're getting 8x squareds, and then for your last term, you're getting 16. So this does factor as a quadratic into x squared plus 4 squared. So be careful of that factoring. Now you could sit and try to use synthetic division, but I don't think you're going to get an answer because these won't be, these will be two, both of these will have imaginary roots. So I guess synthetic division here would not help you any, now that I think of that. So you just have to make sure that you realize that that is a quadratic that you can factor. Okay, once you have it factored, that was probably the hardest part. So if you didn't get to that piece, stop and see if you can finish it now. But then we're going to use 2 different cases. We're going to use, so technically case 4. We're going to use the fact that this is squared, so we're going to write it as 2 fractions, x squared plus 4 and x squared plus 4 squared. Okay, that's case 2 that says if you have a squared factor, you have to write it to the first and the second. And because this factor is a quadratic, we have to do linears. So this can be ax plus b, and this can be cx plus d. All right, so then we need to get those to be the same denominator. Our denominator is x squared plus 4 squared. So the first fraction we're going to have to do something with, but the second one we can leave as cx plus d because it already has that as a denominator. So the first one we just have to multiply by x squared plus 4 over itself. And I can FOIL that out as we go. Remember, it's x squared plus 4 times ax plus b. So I'm going to get ax to the 3rd. I'm going to get bx squared. I'm going to get 4ax. Don't really have enough room here. And I'm going to get 4b. Plus that. All right, that all has to equal x to the 3rd on the top in the numerator. Okay, so let's set up our system of equations. For the x to the 3rds, I have a has to equal 1. That's easy. For x squareds, b has to equal 0. For the x's, 4a plus c x, so plus c. So when I'm looking at the x's, 4a plus c has to equal 0. And if a is 1, c is going to have to equal -4. Oops, sorry, I'm running out of room there. And then for the numbers, I have 4b plus d has to equal 0. And since b already is 0, that tells me d also has to be 0. So I got my a, b, c, and d. So the solving of the system was a little bit easier because a was given to be 1 because there was only 1x to the 3rd. There was only 1x squared, so that means that had to be 0. There were 2 x terms, but since I already knew a, I could find c very easily. And there were 2 numbers, but again, since I knew b was 0, I could find d pretty easily. So you didn't really need to do too much of the system on that one. It was just making sure that you saw the setup of how you're, first of all, how you're going to factor that. Second of all, then, what the setup is. If this one already is there, I just left it. This one I had to multiply by one of those factors. And the case that they were both linears on top because of that x squared plus 4. So let's finish this. We have to write the answer. We have a lot of zeros here, so that's a little confusing. So the a, my a, it was ax plus b. So that means it's going to be 1x plus 0. So just x on top of x squared plus 4 plus, on this one, c is -4 and d is 0. So when I put it back up here, it's going to be -4x plus 0 over x squared plus 4 squared. So when you have zeros, it just means that you go back up to here and that just becomes a 0. So when b and d were 0, that just meant I had ax plus 0, and over here I had cx plus 0. So there's my final answer of that one. And then for the last one, I think this is one that it looks like it's quadratic, and I'm guessing, I mean, we could try to factor it. Actually, maybe it does factor. Let's try. 3x and x, and then to get a, or not 3x and 2x, sorry about that. 3x and 2x, and to get a 2, if I put a 2 here and a 1 here, negative 4x plus 3x is negative 1. It does factor. And so this is one I just wanted, I think, put on there to make sure I show you that you can have coefficients of those two. Sometimes I think most of what we do doesn't have coefficients, but I wanted to show you one that had a coefficient. Same thing, we're going to set it up as a over 3x minus 2. That's one factor. It's linear, so I just have an a. This is linear, so b over 2x plus 1. So I need to change both of those to have a 3x minus 2 and a 2x plus 1. So both of my fractions have to have 3x minus 2 and 2x plus 1. So the first one, I have the 3x minus 2, so I'm going to multiply by 2x plus 1. So I get 2ax plus a. For the second one, I have the 2x plus 1. I have to multiply by 3x minus 2. And so I get 3bx minus 2b. All of that equals x over 3x minus 2, 2x plus 1. So I set my numerators equal. And so my system will be with the x's. I have a 2a plus 3b. That has to equal how many x's I have over there, which is 1. For the numbers, I have a minus 2b. The numbers over here have to equal 0. So there's my system of equations. 2 equations, 2 variables. We just need to get opposites. Let's multiply this one by negative 2. I'll eliminate the a's. And so I have the first equation as is. Second equation. Don't forget 0 times negative 2 is 0. Very common mistake for people to tell me that's negative 2. All right, when we add these, we get 7b equals 1. This is going to be ugly. b is 1/7. And now I need to figure out a. So let's plug it back into, doesn't really matter. Let's plug it in the top equation. 2a plus 3 times b, so 3 times 1/7 is 3/7 equals 1. I don't like working with fractions, so I would probably at this point multiply by 7 and say 14a plus 3 equals 7. So 14a equals 4. Divide by 14, I get 4 14ths, which would be 2/7. A is 2/7. All right, so this one wasn't hard, algebra to solve, but you got some weird answers. A is 2/7 and B is 1/7. So we put that back in up here. If A is 2/7, that would be 2/7 over 3x minus 2, plus B is 1/7, so 1/7 over 2x plus 1. And now I need to get rid of my denominators. So I'm going to multiply by 7 over 7, so I'll get, here they'll cancel, I'll get 2. You don't have to distribute the 7. You can if you want. Here the 7's cancel on top, so I get 1 over 7 times 2x plus 1. And there's my answer to number 4. So that one was just a little bit different as far as, just making sure you know that those factors can be any linear factor. That's okay. You still write it as a over 3x minus 2 and b over 2x plus 1, and then go through to find your numerators that you can find your system of equations. Okay, so that was the back page. I think I'll give you one more video just to kind of talk about the system stuff again, just to make sure you're okay with that.